Good morning, dear student. In today's lecture, we will discuss the reactions of metal complexes with nucleic acid. In previous lecture, we already discussed that the interactions of these metal ion and metal complexes with your nucleic acids such as DNA and RNA, that is covalent and non-covalent interaction with nitrogen bases, sugar molecules, and the phosphate group. So in this lecture, we are very much interested in the reactions of these metal complexes with nucleic acid. If you consider the reactions of these metal complexes with these nucleotides, so these are the polymers. If you consider the nucleic acid, it is a polymeric material, so it is considered as a polynucleotides. It falls into two category, that is, one is a redox reaction and second is the coordination, that is the hydrolysis reaction. So the reactions are of two type of reaction. One is a redox and second is hydrolysis. One is a redox reaction and second is hydrolysis reaction. So we are very much interested in the first reaction, that is the redox reaction. So what is this redox reaction? So we are very much familiar with this redox reaction. In redox reaction, there is a oxidation of the nucleic acid. So you should remember, oxidation of nucleic acid. Oxidation of nucleic acid. In oxidation of this DNA or RNA molecule, direct metal complex is not used. So it is an indirect method for the oxidation or the cleavage of DNA molecule. So for that purpose, a Fenton reagent is used. So for redox reaction or the cleavage of this DNA fragment, a Fenton reagent is used. Fenton reagent is used. So what is this Fenton reagent? It is Fe second with S2O2, in presence of S2O2. So the Fe second complex, metal complex, interact with S2O2, and which results into the formation of hydroxyl radicals, and these radicals are interact with your nucleic acid molecule, and it undergo and it results into the cleavage of this DNA fragment. So you should remember, in the first, that is redox reaction, there is oxidation of nucleic acid. So indirect oxidation of nucleic acid by the metal complexes, because these metal complexes not directly involved in the oxidation reaction or in the cleavage reaction, but whatever the active intermediate active radical which is formed after reactions of this metal complex with S2O2, it will catalyze the reaction, that is, it will catalyze the cleavage reaction. So let us discuss this reaction. If you consider Fe, so let us consider, in this case, we consider it is as Fe second EDTA complex, ethylene diamine tetraacetic acid having -2 charge. So if you consider this Fe, it is in +2 oxidation state. It will react with your S2O2, and there is a oxidation of this Fe from Fe second to Fe third with formation of hydroxy radical and hydroxyl ion. Hydroxy radical and hydroxyl ion. Again, this Fe third, it will take one electron. It will take one electron and convert into Fe second. So this is the primary process. So this metal complex is not directly used in the cleavage of this DNA fragment, but whatever the hydroxy radical which is formed in this reaction, it is used for the catalytic cleavage of DNA fragment, catalytic cleavage of DNA fragments. So let us discuss the next reaction. So this ferrous ion or the complex, it is not directly involved in the cleavage of nucleic acid molecule, because so why it does not involve directly in the cleavage of DNA molecule? Because if you consider this complex having a negative charge and it is a chelated anionic complex, they are repelled by the nucleic acid polyanions. So the nucleic acid, if you consider, it is also having a phosphate group and nitrogen basis, and therefore it is also in anionic form. So there is a repulsion between these DNA molecules and these metal complexes, and therefore this cannot use directly. Instead of this, whatever the hydroxy radical which is formed, they are used to cleave the DNA molecule. So let us discuss the reaction. So let us discuss the reaction. So this is your, let us consider this is your base, this is your DNA fragment, this is your oxygen, it will binds with your phosphate residue, again it is bind with oxygen, it is bind with the another molecule, so it is a polynucleotide. This is base 2 is there, again there is a O, P double bond O minus is there, and so on. Again O is there, CH2, and this is your R group we consider here. Again here is also it will bind the oxygen, and there is a P double bond O minus, and this is having R group, we can consider this as R group. So this is your DNA fragment. So this DNA fragment, it will interact with your hydroxyl radical. So these hydroxyl radicals, when interact with this DNA fragment, it will abstract the hydrogen from C1, C4 and C5 position. So we already know that is this is your carbon number 1, 2, 3, 4 and 5. So it will abstract hydrogen from C1, C4 and C5 carbon. So this is your C1, then it is your C4, and this is your C5 carbon. After abstraction, so it will abstract the hydrogen from C1, C4 and C5. After abstraction, it will generate, so there is a formation of the radical carbon. So after abstraction of this hydrogen, there is a formation of radical carbon, and which is unstable and which is try to get stable by the cleavage of these DNA fragments. So what happened? Let us consider in this case, for example, if you consider in this case a C4H hydrogen abstraction is there. C4H hydrogen abstraction is there. So this hydrogen is abstract by these OH radicals. It is not OH minus, sorry, it is N radical. So this hydroxyl radical, it will abstract this proton, and there is a formation of a radical carbon. So in this case we can write this as P, this is your R double bond O minus, this is your O, this CH2 is there, oxygen, like this. This is your B1 is there, and we can consider this whole group, it is considered as the R group. For our simplicity, we can consider this other groups are considered as a R group. So after abstraction, so there is a radical formation is there. Then this radical, again there is a radical formation, because if you consider the bond between this carbon and this oxygen, it will cleaves to gives a radical formation. So what you get here, we get here p double bond o r o minus, having o radical, and this radical, so in this case here is a radical. So these two radicals, radical recombination is there. After breaking of carbon oxygen bond, there is a radical recombination, and what you get, we get double bond cs2. This is your oxygen, this is your b1 is there, and the remaining r group is there. So there is a different ways of cleavage of this DNA fragment. This is one type of cleavage, that this hydroxyl radical abstract C4 hydrogen. There is a radical formation, and there is a cleavage, and we get the phosphate group is removed from this DNA fragment, and then it will takes H plus to get OH is there. So there is a cleavage. So this is one kind of cleavage. Another cleavage is that, let us discuss the another cleavage. So this is one type of cleavage. So we are very much interested in the cleavage of this DNA fragment. So it will abstract hydrogen of C4, which results into the formation of this. So let us discuss the second abstraction. For example, in this case, we discuss, let us consider for a C1. So hydroxyl radical, it will abstract the hydrogen of this carbon number 1. So what you get here, oxygen, it having radical, it having b1 is there, the whole group is there, p double bond o minus, and let us consider this is r group is there. Okay, and this is also your cs2o, this is your p double bond o minus, and this is your r group is there. Okay, the another route is that it will abstract the proton formation of radical carbon. This radical carbon, it will interact with your molecular O2. This radical carbon, it will interact with your molecular O2, and there is a formation. So what you get in this case, we get this, that is O. So the oxygen is bind to this carbon, oxygen radical is there, this is your b1 is there, this is your cs2o, this is your p double bond o minus, this is the r group is there, again o, p double bond o minus, and this is your r group is there. So the second route is that it will bind with your molecular oxygen, and what you get after that, when this radical, so if you consider there is a elimination, of the nitrogen base, in this case nitrogen base. So in first mechanism, when it interact with C4 carbon, there is a elimination of phosphate group, but in this case when this hydroxyl radical it interact with your C1 carbon, then there is a elimination of this nitrogen bases, considered as a B1. So when this bond is break, so again there is a radical formation, radical formation. So what you get here, so there is a radical, oxygen radical is there. Okay, and then this is your oxygen, and then it is attached to phosphorus double bond o minus, this is your r group, and then radical recombination, which results into double bond o, which results into double bond o. which results into double bond O. So what you get here, yeah, double bond O is there. I think I will make a mistake in that case. So in this case, let us consider once again. So we can write here once again. So we can write here. So oxygen is there, and there is a radical. So what happened when this bond is break? So there is a formation of radical again. This bond will break, gives O radical. So what you get here, okay, there is a radical, this oxygen having a radical, this B1 is removed as a radical, and there is the elimination of oxygen, and this radical recombination, so remaining group is same, and we get here a double bond O is there, and this is our R group. We can consider this is our oxygen, and this is our R group we can consider. So there is a different way of the cleavage. So first there is a formation of removal of the phosphate group. In the second mechanism, when this hydroxyl radical abstract hydrogen, then the radical, it will interact with molecular O2, and then this molecular O2 undergo cleavage. So this radical O2 radical interact with this nitrogen base, or there is a radical formation which results into the removal of this nitrogen base. So elimination of this B1, which results into the formation of this product. So there is a different ways of cleavage of this DNA fragment. So you should remember the redox reaction, that it will abstract this hydroxyl radical, abstract the hydrogen from C1, C4 and C5 carbon, and then the radical carbon is generated, and there is a elimination of phosphate, nitrogen bases group, and the sugar molecule is there. So this is regarding to the redox reaction of these metal complexes with nucleic acid. You should remember the Fenton reagent, because not directly the metal complexes is used in this cleavage, but whatever the hydroxyl radical which is formed after reaction with S22, it will results into the cleavage of this DNA fragment. So in next lecture we will discuss the second type of reactions metal complexes with nucleic acid, that is the hydrolysis reaction. Thank you.